In this tutorial we're going to be having a look at arithmetic sequences, in particular a harder exam question to do with summing arithmetic sequences. So it says a sequence U1, U2, U3 is defined by U1, the first term, equaling 8. Let's write that down straight away in sequence notation. A, the first term, is 8. And what it says here is that the next term is got by taking the previous term and adding 3. So from that we can see the common difference is 3. Okay, show that U5 equals 20. Well, again, looking at our formula sheet, we see that the formula for the nth term is A plus n minus 1 d. So we want the fifth term, U5, is equal to the first term, 8, plus n minus 1, 5 minus 1, which is 4, lots of 3, which is equal to 20. 8 add 12 is 20. And that's enough working to pick up the marks. Okay, part 2. The nth term of the sequence can be written in the form un equals pn plus q. State the values of p and q. Well, again, we can just use this formula here. The nth term is the first term, 8, plus n minus 1 d. So if we expand that, 8 plus 3n minus 3 equals 3n plus 5. And there we have it in the form pn plus q. So p equals 3 and q in this case is 5. Part 3. State what type of sequence it is. Arithmetic. A sequence with a common difference between terms. Finally, part 4, and this is the difficult part, worth 5 marks. Find the value of n such that that sum there, take that sum there, is 1, 2, 5, 6. Well, this first summation is summing all the terms between the first and the 2nth. So what it's asking us to find is s, 2n, the sum of the first 2n terms. So the formula, again consulting our formula sheet, is Sn equals a half n 2a plus n minus 1 d, or a half n a plus l. Since the summation starts from term number 1, the better formula to use is this longer formula here. So the sum of the first 2n terms, well, in this case, a, the first term, same sequence as before. The first term is 8, the common difference is 3, and little n, the number of terms we're summing, is 2 lots of capital N. So, filling that in, a half 2n, 2 lots of the first term, plus little n, which in this case happens to be 2n minus 1 d. And let's simplify this from the inside out. It's much easier to simplify from the inside out. So a half 2n 16 plus 6n minus 3 equals a half 2n, let's push the paper up there, half 2n 13 plus 6n, and then a half times 2n is just n, equals n 13 plus 6n equals 13n plus 6n squared. And we've simplified that as far as we can. Now we're going to do exactly the same thing for the sum of all the terms from 1 to capital N. So s capital N equals a half capital N 2 lots of the first term plus little n, which happens to be capital N in this case, minus 1 times 3 equals a half n 16 plus 3n minus 3 equals half n 13 plus 3n. Simplifying that one step further equals, well, a half n times 13 is 6.5 n plus 1.5 n squared. Right, so we've got the two individual summations now. So what we need to do now is subtract them from each other. So s2n minus sn equals 13n plus 6n squared. Take 6.5n plus 1.5n squared. Subtracting that, well, 13n take 6.5n is 6.5n. 6n squared take 1.5n squared is positive 4.5n squared. And we're told that that's equal to, according to the question, 1256. And what we've got here is a quadratic. So let's rearrange it. We've got 4.5n squared plus 6.5n take 1256 equals 0. And now we're left it in a form that's solvable. So let's use the calculator quadratic function to find out what the solution to that is. So it's a polynomial of degree 2, and it's 4.5n squared 6.5n and minus 1256. So the answer, n equals 16, or minus 157 over 9. Now, because n is a term number, it must be an integer value, so that there is an invalid solution. The answer is n equals 16. For more videos like this, go to alevelmathsrevision.com.